Good afternoon, members. My name is Marcus James. I manage Office and Administrative Services here at ACA. And if this is your first time joining us for the series, welcome. And if you're familiar with the series, welcome back. A couple of administrative notes before we begin. Attendees are in listen-only mode, and we would like you to please enter your questions in the questions dialog box. And we'll have a Q&A at the end and have your questions answered at that time. There's also a brief survey at the end, and we would appreciate your feedback on that. And finally, if your slides seem to run slowly, it may be a bandwidth issue. They will catch up, but if we have a problem on our end, we will inform you about that and get it fixed as quickly as possible. I want to introduce you to today's speakers. First is Eric Casebolt. Eric joined ChemQuest in 2023. An accomplished global leader with a proven track record of providing viable solutions to organizational goals. Eric's career started at Johnson Polymer and evolved to include roles with BASF and Eastman Chemical. Utilizing a combination of technical and marketing expertise, he has spent considerable time leading product development teams and helping to transform business strategies. Nathan Biller began his career in the powder coatings industry in 2001 with Jamestown Powder Coatings, later joining Powder Coating Research Group, which was acquired by ChemQuest in 2021. He soon emerged as the team's lead formulator, tackling complex formulation challenges in numerous industries. Nathan assists clients in navigating strategic and business challenges, and his technical skills continue to lead to numerous technology development advancements. And now I will hand this over to Eric to get us started.
Thanks, Marcus. Hello, everybody, and welcome. And I appreciate everybody attending. Looks like we have a pretty good audience. Just one thing real quick. Feel free to ask questions throughout the presentation using the chat box. Marcus will be monitoring that, and Nathan and I will be kind of keeping an eye on it. And if it's convenient, we may answer those, during the presentation. But if yours isn't answered during the presentation, don't worry about it. We will try to get to them all at the end of the presentation. Okay, Marcus, we can start going through the slides. So this is the agenda for today's conversation. First of all, we're going to do a one-slider introduction to ChemQuest in case you don't know who we are or what we do or why we're presenting to you today. And then we're going to go through my section, which is the architectural coatings market overview. Just real quick, this is not to be confused with decorative paints. So it's not wall paint. We're talking about coatings for architectural extrusion, and I'll get into that in a few slides. But we'll talk about market size, value chain, the application process that's used, and why people would choose powder coatings versus liquid coatings in this particular segment. And then Nathan will take it from there and start going through some formulation aspects of the powder coatings for this field. So we'll talk about formulating for outdoor durability. That section is going to be a relatively high level. We do have deep dive trainings into powder coating formulation. If you're interested, reach out to us. This will be more about the binder chemistries and some kind of general do's and don'ts about the formulation side of things. And finally, we'll have one slide that talks about active areas of research in architectural coating. So what's going on in this market today? What are people working on? Next slide, Marcus. Okay, ChemQuest. So who is ChemQuest? At a high level, we're a consulting firm, but we're a lot deeper than that. When we work with our clients, a lot of times we refer to ourselves and they refer to us as strategic thought partners. And the reason for that is because we're niched down into the chemical industry, and we have a lot of experience specifically in the coatings industry. And if you look at those four we refer to those as pillars in the middle of those red boxes. Pillars are buckets of work that we do. That's not the best use of words. We talk about them like that, but they very much blend together and are used in combination. And so to just go quickly through those, the top one is business strategy and transformation. We do a lot of work trying to help companies meet their objectives, whether it's going into an adjacent market and understanding the innovation drivers in that market and the sizes of the market, or if they're trying to revamp their whole strategy. For example, their products are getting commoditized and they need a new way to attack the market so they can stay differentiated. We can help with lots of things around those aspects. That second box is technology development. And we have 2 labs. We have a powder coating lab that's in Columbus, Ohio, and we have a liquid and adhesives lab, and we also can do plastic compounding, and that is in South Boston, Virginia. So we get involved pretty heavily with raw material suppliers, coating companies, and end users who are trying to understand how their products work or develop new products. And we actually are a full service lab, so we can formulate, we can do the formulations, and we can evaluate the products and help develop value propositions and prove out value propositions. The third box there, operational and manufacturing efficiencies. Take, for example, one company buys another company, and now they have a new set of assets. We can help streamline those assets so that they're using them in an optimal manner. And finally, we do M&A advisory services. We do both the buy side and sell side on merger and acquisitions. So if you're looking for any of that stuff, feel free to reach out to us. But today we're going to talk specifically around powder coatings, and we'll hit a lot on the technology side of it. Next slide, please. Next slide, please. So now we're going to get into it, the subject for today, which is architectural coatings. But first, we need to define the market. For the purpose of this conversation, we're going to define the market as factory applied coatings over extruded aluminum for use in building and construction applications. What this means is we're specifically excluding coil coatings, which are used heavily in architectural applications, and field applied coatings, because we don't want to get involved in that gray area between what's an architectural coating versus what is a protective coating or an industrial maintenance coating. So as we go through this, just keep in mind we're talking about factory applied coatings over extruded aluminum. The types of products that those go on, so if you're thinking about, well, where are those used really on a finished product, there's a list of it down the left side. The main ones that we talk about usually are doors and windows, storefronts, which if you went and you saw a Starbucks or a McDonald's and you just look at the front of it, that's referred to as a storefront, but that's a specific type of product that is sold into the market. Is a storefront. And finally, curtain walls down there. If you don't know what a curtain wall is, that picture on the bottom right is a curtain wall. So if you look at a lot of the more modern buildings, it just looks like a wall of glass with some pieces of aluminum in between. That's referred to as a curtain wall. Obviously, these kind of things can blend together somewhat too in the different categories there, but that gives you some idea of where these are used. Next slide, please. Okay, so market size. When you look at the architectural coatings market here, you'll see on that subtitle up there, powder coatings make up about 15% of the coating volume and 25% of the coating value. This market is dominated. I have liquid coatings written there, but this market is dominated by powder coatings and solvent-borne coatings. There's hardly any waterborne coatings used in this market whatsoever, so it's essentially zero. So it's solvent and powder coatings. And so if you look at the split there, the market size by volume is about 18 kmt by our latest estimates, and the value is around $220 million. And as I said before, you can kind of see the split on those bars. If you're looking at value, powder coatings is about 25% of that value, and liquid coatings is about 15% of the value. I guess I should back up and say when I'm talking about this, I'm referring specifically to the U.S. market. These are not global numbers. And so if you're trying to look at another way to segment it, you can do powder versus liquid and understand that aspect of it. But if you start digging deeper and talk to people in the industry, what they're usually going to refer to are specifications called the AAMA specifications. And on those sub bullets to the right, you'll see AAMA 2603, 2604, and 2605. They're usually described, they have different specifications and different requirements for a variety of tests. So there's a laundry list of tests if you're trying to get qualified for these, and that's at a coatings level, not at a, for example, resin level. So you would have to qualify your coatings to be part of these specifications. But usually when people refer to them, they differentiate by the weathering requirement, because that's the biggest difference. And so AAMA 2603 is a 1-year weathering specification. AAMA 2604 is a 5-year, and AAMA 2605 is the most stringent and requires a 10-year weathering specification. Were you going to say something, Nathan?
I'll cover these things in a little bit more depth. My section, I'm going to talk about, not only the powder chemistry, but also some of the specifications that determine where a powder coating fits in, as well as some of the test methods that we use.
That's great. And then that final bullet point there, and he'll talk about this also, similar specifications exist in the other regions. In Europe, they're governed by Qualicoat and GSB, and Nathan will get into the differences between the AAMA, the Qualicoat, and the GSB in his section. Next slide, please. Okay, so when you look at material flow, it gets a little bit complex pretty quickly. And it's all complex around the coatings aspect of things. So if you take a look at those light blue boxes there, the first thing you'll see is you have coating raw material suppliers, and they sell raw materials to the coating manufacturers. And the coating manufacturers will formulate and manufacture coatings and sell them into this market. After that, it gets a bit confusing. So step down to the dark blue box where you see aluminum extruder. So if you start there and ignore the part about the coating for a second, the aluminum extruder, if you're going to make a window, for example, you have an aluminum extruder that's going to make the aluminum and the shapes required to make that window. We're talking about aluminum window, obviously, here. They're going to sell that product to a fabricator or a window manufacturer. And those are not always integrated, but we're just keeping them in the same box for now because quite often they are integrated with each other. And I'm talking about the fabricator and the window manufacturer. So they're going to sell the aluminum to those people. They're going to make the product, the final product. In this case, I'm talking about a window, and they're going to sell that to a builder, which is going to be used at the job site. So that's how that flow goes. But it gets a little bit more confusing when you talk about who's putting the coating on. And that's where all of those arrows are pointing in different directions in the middle of the slide. So everywhere you see a star, there are areas where those are the nodes that can actually do the coating. So there's a lot of different places that can be back integrated to putting the coating on. So for example, the aluminum extruder could make the aluminum and then coat the aluminum before they ship it out. Some have that capability and some do not have that capability. If they don't have that capability, there's still a couple different options. They can sell it directly to the window manufacturer or fabricator, and those companies, if they're large enough, can be back integrated to put the coating on. So they may put the coating on themselves and then make the window and then sell that to the end user. There's another piece here, and it's called a custom coater. If the aluminum extruder does not coat the product, and the fabricator or window manufacturer doesn't coat the product, what they'll do is they'll have the aluminum sent to a custom coater, which is a third party that just specializes in putting coatings on products. And in this case, on aluminums for architectural applications. So the aluminum will be sent there. They will coat it with the required coating, and then they will send that material to the fabricator and window manufacturer. The point of this is there's a lot of integration within this value chain, and there's multiple players on the value chain that could be applying the coatings. Next slide, please. Okay, so what about the application process? How are the coatings applied if you can actually figure out who's applying it? Well, this process is I'll say relatively complex. It's also very automated typically. Because these products, these coatings have to last many, many years, especially if you're talking about on monumental buildings like stadiums and such, or skyscrapers, they have to last a lot of years and nobody wants to repaint them, you know, many, many floors up. So because of that, the process, regardless of who's doing the coating, the application, I should say, the process is audited by the coating suppliers to ensure the highest level of quality and consistency. This also helps out with warranty issues. So should the coating fail, you don't have two different people, in this case, the coating manufacturer and whoever applied the coating, pointing the finger at one another and saying whose fault it is. So to solve that type of problem and to make sure everything is applied properly, they work together to make sure that the full coating process is such that you're going to get very high level of quality and consistency. So let's get into what that process looks like at a high level. First, you have, so typically if you went to some place that was doing like a custom coater, they just specialize in coating application, the room would be taken up, especially the outside of the room would be taken up by large pieces of equipment that are used for this process. And usually there's going to be a conveyor belt going from one stage to the next around the building. And so the first stage is racking. So what I mean by that is you're going to have either a horizontal or vertical line, and I'll talk a little bit about that in a minute. But if it's a horizontal line, you're going to have people actually hanging parts on hooks on a conveyor belt or some type of system on a conveyor belt so that they can go through this process. Once that happens, the conveyor is going to take it through a pre-treatment process, which is usually a 5 to 7 stage process to make sure that you're going to get all of the adhesion and the corrosion resistance that you need out of your coatings that you're putting on there. Next, you go through the coating process, and that's different depending if it's a liquid or a powder coating. But I'm going to stay on this track just to finish that up, and then we'll get into a couple of details on the horizontal versus vertical and the different types of coatings that are used. But the coating is going to be applied, and then you're going to go into an oven where the coatings are cured. These are both, whether it's solvent-borne, I almost said solvent-borne or liquid-borne, whether it's solvent-borne or a powder coating, both of them are baked coating, so they have to be baked at a relatively high temperature to cure and get the properties to flow out. And finally, those are going to be pulled off of the conveyor belt and they're going to be packed and shipped to where they need to go. Now, I mentioned a couple of things. On the first node there, I mentioned racking, and you see underneath that it says horizontal or vertical application line. The difference between those is literally what it sounds like. Some of them, the horizontal line, people are hanging parts on, and they can be lots of different shapes and sizes. The advantage of horizontal lines, for one thing, they're cheaper to install, so you have lower initial capital costs, but you also have flexibility because they're not just made to do aluminum extrusions. They can do lots of different sizes and shapes of parts as long as you can get it to hang on the conveyor belt, hang on the rack, and fit into your coating application process in ovens. A vertical line is optimized for running aluminum extrusion. So it's what it sounds like. You have a machine basically where you set these aluminum extrusions, which can be up to about 30 feet long, and they'll actually turn them vertical, and it'll make almost a wall of aluminum extrusions, and they will go through the line that way. Now, those are quite a bit more expensive, but the advantage is they're a lot more efficient. So your coating efficiency is better because you're coating almost a wall of material as opposed to vertically stacked things. And your throughput is much faster because it's just designed to move that through the process a lot faster because all you're coating really with that is aluminum extrusions. Now, if you get into the coatings I mentioned, and you have two little boxes down there, today we're talking about powder coatings, but we also have to talk about liquid coating so you can kind of compare and contrast the two. If you're using a liquid coating, which is the one on the right, your transfer efficiency is actually pretty high. It's about 85%. And when I'm talking about transfer efficiency, what I'm referring to is if you had a can of spray paint or something like that, and you're spraying a piece in your garage or in your yard, a lot of that overspray is going to go past the part and cannot be regathered or reused. Well, these are applied, even the liquid coatings are applied, the highest efficiency ones are applied using an electrostatic bell sprayer. And those have pretty high application transfer efficiency. And so what I'm saying here is about 85% on average of that material is going to hit the part and be usable. 15% will go past the part and is wasted. On the powder side of things, you have about 95% transfer efficiency is usually the number that's quoted. The reason that one is higher is because it's also electrostatically applied, so it's going to hit the part for the most part. Most of the material is going to hit the part and stick to the part and be able to be used, but what goes past the part can also be reclaimed and recycled. So the application process is set up so that material is captured and recycles through and continue to be used as long as you're spraying the same chemistry and the same color for long periods of time. Now, when you look at the differences between the two pictures down at the bottom, powder coating application, usually your top coat is going to be around 70 microns. I mean, it varies pretty widely, but on average, 70 microns is about a decent number to say what's the average film thickness. You notice that there's no primer used on powder, and that's generally the case. When you talk about a liquid coating application, it's almost always using a primer, and the primer layer is about 5 microns, so a very thin film of a primer to help out with the corrosion resistance and adhesion. And then your liquid coating application top coat is about 35 microns. So overall, even though it's 2 layers, that's almost half the film build that you'll get with a powder coating. Nathan, you have anything to add on here?
No, it's all making sense to me.
Trust it. All right. Thanks. Next slide, please. So advantages of liquid coatings and advantages of powder coatings. What I typically say is they both have advantages and disadvantages, and you should use them in the right situations. But since these are all going towards architectural coatings on aluminum extrusions, there certainly are pluses and minuses. And so if you look to the left side here, well, what I say on the top bullet point is, and it's important, is that both of these can meet the AAMA 2605 specifications. I know powder coatings, I mentioned earlier that they're a much smaller market in the US, but these are used pretty extensively in other parts of the world, like Europe. You talk to people in Europe, and a lot of times they'll say, well, if a powder coating can be used in this market, it will be used. That doesn't mean it's 100%, but it's used quite often in Europe. So the reason it's not used in the US is not because they can't perform well. They both can meet the most stringent specifications here. But when you look at advantages and disadvantages of each, the liquid coatings, they offer a wider variety of colors and shades. And when I say that, I'm talking about, when I say shades, I'm talking about the gloss range. So the gloss ranges are easier to manipulate in liquid coatings than they are with powder coatings. They still have a pretty good range in powder, but it's just not as wide as it is in liquid. And we're talking colors here. I'm talking mostly about things like metallics and other types of effect pigments. Those just show up a lot better in liquid coatings than they do in powder coatings. Powder has made a lot of gains to close that gap over the years, but liquid coatings still excel in appearance with those types of coatings. Lower coating cost as applied. As I mentioned, the liquid coatings are applied at a much thinner film, even though you have two different layers. It's thinner, and those products are also cheaper. So your raw material cost is cheaper, and then your application, your film build is a lot lower also. You have shorter lead times, and this will be, when I'm talking about lead times here, I'm talking about if somebody wanted to put like a custom color on a window or a product. The reason it's shorter is because liquid coatings can be color matched much easier than powder coatings. In fact, a lot of applicators in this field have a system. I'm worried about using a trade name. They have a system in-house where they can, they know if they have certain colors in stock, they can use 2 or 3 of those colors to color match on site. They don't have to order it from the coating supplier and wait 2 to 3 weeks for that to be shipped. That's not the case with powder coatings. You can't just mix a final product and come up with a different color. You'll get like a salt and pepper if you mix a black and white. So they do have to order custom colors from their coating supplier, and that creates a longer lead time. Now, what about the advantages of powder coatings? That first one is by far the highest one on this list. It's the material of choice when sustainability is prioritized. And you will hear a lot of back and forth between liquid coating, people who are advocating liquid coatings and powder coatings about which one truly is more environmentally friendly. And there's a lot of valid reasons for both. But if you ask anybody along the value chain why powder coatings are used, they're almost all going to say it's because they're better for sustainability. So if you care about sustainability, powder coating is the choice. Why? Well, the next bullet point explains it pretty well. It's 0 VOC is the main reason it's touted, and then the transfer efficiency is a little bit better, so that's also touted. But the second bullet point also points out something else. It eliminates the requirement for an abatement system. When I'm talking about an abatement system, what that is when you're applying solvent-borne coatings, you can't let all of the solvent evaporate and go into the environment. What you do is you buy an abatement system that essentially burns that material, and usually, well, I think always, uses the heat for something else, either to heat up. Ovens are talked about to heat up, to use heat for the facility is talked about. Anyway, so that's a good way of utilizing those VOCs that have to be evaporated anyway, but it's also expensive. So liquid coating plants are generally more expensive to install or to have installed than powder coatings, and a large part of it's because you need an abatement system. It's a one-coat system. We talked about that. It doesn't require a primer. Higher transfer efficiency we talked about, and lower bake temperature. Both of them have pretty high bake temperatures. And I believe, if my memory serves correct, the liquid cure cycle is a bit lower, and I'm sure that can be modified by temperature. But powder coatings are, in fact, usually baked in this case at a lower temperature than the solvent-borne counterparts. Next slide, please. All right. it's Nathan's turn.
All right. Happy Thursday, everybody. I'm going to talk a little bit about the general types of powder coating chemistries that are available, where they fit into the architectural market, as well as some of the specifications that Eric briefly touched on, and then how we do testing for those types of specifications. So this slide talks a little bit about weathering test methods. Really, the gold standard, the king of the UV durability test methods is just putting it outside in Florida and waiting a long time. That's the most relevant and the most repeatable sort of method, but it's not really practical to take every single formula that you make and leave it in Florida for 10 years and see what happens. So we have a variety of accelerated test methods that we can use. There's QUV, which is a test chamber. Oh, there's one behind me there, but they're, depending on what sort of bulb you use, it has peaks in different kind of wavelengths, and it's basically a very aggressive test that is mostly UV light, and it's very hard to correlate to Florida though, and so you can compare different materials with each other and see which ones are perform better, and you can also take materials with known Florida performance and compare your formulations against those. Xenon arc is a lot closer to actual sunlight as far as the spectrum goes. It's still an accelerated test. It's still done on a laboratory setting, but the wavelengths match up with sunlight a little bit better. And then Amakwa, that's a solar concentrator test, and those are typically done in Arizona, where the parts are put out on these devices that focus the light onto it, and so you have actual sunlight. It's just highly concentrated, and so you can speed up a Florida test by doing that. Can I get the next slide, please?
I think it's worth pointing out that I think most people on here are coatings people, it looks like, but in case you're not, the specifications are written around South Florida. The rest of the tests are all designed to try to get a feel for what's going to pass and what's not going to pass those types of South Florida weathering, right?
Yeah, exactly. So the major specifications that we refer to with architectural coatings, it's AAMA. It's actually now called FGIA, which I'll never get used to, but the Fenestration and Glazing Industry Alliance. That's the major one that's used in North America. The interesting thing about the AAMA specification, though, it's a self-certification. There's not, a board or a body that says that you are not compliant with AAMA specifications. That's up to the paint manufacturer to specify, yes, this material is going to meet the requirements of this different level of AAMA specification. And so it's up to the paint maker to make that claim, and also to back it up with data or with a warranty if they don't meet it. Qualicoat, on the other hand, that's a European standard. We're starting to see it a little bit here in the States as well, but Qualicoat does have certified labs that have to do the testing to specify, yes, this this coating meets the requirements of whatever the specific qual code is. There's the next slide. I think there's going to be a little bit of reference to those different specification levels, and you can see that they kind of have similar categories as the AAMA tests that we're used to. And then I mentioned GSB. This is specific to, it's a German specification, but I've seen they have their own table of corrosion resistant specifications that I've seen referred to outside of, outside of the specifically German paint coating. So it's good to know that. Next slide, please. All right, so Eric touched on this a little bit, but this gets a little bit more in depth. AAMA 2603, 2604, 2605, those are the major categories that we can specify architectural coatings into. South Florida weathering, it's 1, 5, and 10 years respectively. And even the gloss retention, you see for the 2605 is a higher requirement than it is for the other ones. There is a salt spray corrosion requirement for these. Since it's on pre-treated, typically chromated aluminum substrate, we really don't, with powder coatings, we really don't have a problem hitting high levels of corrosion resistance on aluminum. If it's on steel, 1,500 or 3,000 hours might be tricky to get with a single coat. But yeah, with properly treated aluminum, these are not that difficult. But there is a difference in test methods between the 2603, 2604. Those are a neutral salt spray, 5% salt solution, constantly running. ASTM B117 is kind of the most common salt fog or corrosion resistance test. The difference with 2605, it's called ASTM G85 Annex 5 or Prohesion. It's a more dilute, solution, but it's also acidic, and instead of constantly running the fog, there's an hour of fog and then an hour dry off period at an increased temperature. And so it's really aggressive. Instead of, you'd think that just spraying salt on things 24 hours a day would be pretty aggressive, but actually going through the process of fog and then drying and then fog and then drying and fog and drying for 2,000 hours, it's a pretty aggressive test. And so that's what they expect for the highest level of protection.
Yeah, Nathan, just to add on, I know I mentioned earlier that there's if you go into the AAMA specifications or the Qualico for that matter, there's a laundry list of tests. You're just showing here the weathering and corrosion, but if you get it, if anybody looks at the specs and you're not aware of what's out there, you're going to see impact resistance, falling sand, chemical, even mortar resistance. There's a laundry list of tests, but this is typically what's talked about, what Nathan's showing here when people are differentiating between that, 2604 versus 2604 versus 2605.
These are the big differentiators. Like powder coatings, even like a lousy powder coating is not going to have much issue with Windex resistance. Yeah, I'm not sure about, I don't know, solvent-borne.
They don't do that
well, but but,
not these types, yeah.
Yeah, so they're those are, I wouldn't say a given, but I'd say that there's a set of chemical tests, you need to do them, you need to check them out, but powder coatings pretty resistant to those sort of things. Talking a little bit about Qualicoat, there's class 1, 1.5, 2, 3. The interesting thing here is that the color retention actually depends on the color, which is kind of cool. So they have a list, or they have a table of RAL shades of colors that are generally used in architectural, and depending on the color, it might be a very small margin or a large margin, and that's because visually it's very easy to, if you have a like a very light color, like a bright white, and it yellows just a little bit, that's very apparent to the eye. But if you have a darker, deeper color, or high chroma, like a blue or brown, and there's actually a little bit more margin that's acceptable for changing color, because it just visually doesn't look as different. Those ones all have a gloss retention requirement of 50%. And another thing is that they do specify, in addition to the South Florida weathering, which you have to do, there are some accelerated weathering options that you can get an idea of whether or not the South Florida is actually going to is actually going to run the course. So in the case of the 1, 1.5, and 2, they do a xenon arc test, and then depending on the amount of color and gloss that are retained. Sorry, it says color retention percent. I'm not sure what that means, but
yeah.
The accelerated weathering for the 10-year is 3 years Florida, and the column might be needs to be changed, but for these ones, it's a acetic acid salt spray test, as opposed to the neutral salt spray or the Prohesion, or the ASTM G85. Next slide, please. All right, so when we're formulating a powder coating and we know that there's an architectural requirement involved, then you can pretty much categorize all the powder resin types, all the powder chemistries that are out there by their UV durability. And so if I'm asked to make a coating that lasts X years in Florida, like that automatically kind of drives which sort of powder chemistry you're going to have available. Every component of the formula can affect the exterior durability. You can make the greatest, most weatherable stuff in the world, and then you put in a pigment or an additive or wax or some material that doesn't have exterior durability, and you're just not going to ever be able to make it to the full course of the testing. Another thing I put is ask suppliers for weathering data, because as I said, it's not practical to test every coating for 10 years before you sell it to your customer, or 5 years, or 2 years, whatever the requirement is. And so we do rely fairly heavily on the materials having been tested and tested properly to be able to then take that knowledge and that data, translate it into a formula, and then have a high degree of confidence for our customers that we can say, yeah, this, we believe, we certify, we believe that this is going to last 5 years exterior. So this is just an example of some of the powder coating binders that are out there. First of all, if there's an epoxy resin involved in the in the binder at all, it's not weatherable. It's not really an option for exterior durable at all. So there's a couple of, there's pure epoxy, there's polyester epoxy hybrids that we would call either interior grade or functional grades of powder coatings, which are just not, not expected to be to perform outdoors at all. We don't have a 6-week South Florida specification for epoxies, so that's one thing. Architectural, you're not going to be using them. At the lower end of the scale here, we have standard durable polyesters and super durable polyesters. I'll talk about the difference between those, but those are really, really common for 2603, 2604, respectively. And so standard durable polyesters are outdoor coatings. Examples I think over, lawnmowers, bicycles, maybe even screen door, like cheaper screen doors, things that get some incidental exposure to the sun, but they're not part of a structure that's meant to last for decades. Super durable polyesters, that's your 2604 tier. And those are very common for things Eric was talking about, the window frames and parts of storefronts and buildings where it is, it's installed, it's meant to last for a long time, not necessarily, monumental. That's one of the words we use for the fluoropolymer grade up there. Acrylics are an interesting topic. So we have some acrylic people here, but they're really not used in architectural coatings very much. They fall in between. They can easily hit that 2604, the 5-year South Florida durability. The 10-year is kind of, they're kind of in between. And so acrylics, the reasons that they're not used as much in architectural coatings, a couple of reasons. One, they are excellent for very high gloss, smooth, and especially clear coat type of coatings. They fit perfectly into the automotive segment because when you want that high gloss Class A finish, you can get that with an acrylic powder coating. That being said, they're difficult to matte. It's not as common to have acrylics that are in the lower gloss range, and so architectural coatings, all that gloss is not necessarily a good thing. Most of the architectural coatings that you have out there are going to be in like the 20 to 40 gloss units, 60 degrees. So acrylics, they are capable of architectural weathering, but just not that commonly used. And at the higher end of the scale here, we've got fluoropolymers, which that's where, they're pretty much a requirement for 2605 for Qualicoat Class 3 they actually, properly formulated fluoropolymer will overshoot the 10-year Florida requirement by quite a bit. These are more like 25-year coatings.
Nathan, just as a time check, we've got about 15 minutes left, but if we want to leave some time for question and answer, we're going to have to.
All right, I won't. Yeah. Okay. Next slide, please. All right, this is just difference between standard durable and super durable polyesters. For one, that's the terminology refers to the resin, not the actual formulated coating, although I think people do use that term quite a bit. But it's just a monomer change. You go from terephthalic acid to isophthalic acid, and the UV durability is increased by quite a bit. Besides that, the polyesters are very similar to each other. They can be acid functional, they can be hydroxyl functional, standard bake, low temperature cure bake. And I've been asked, like, well, if it's a super durable is more durable, then why don't we just use that for everything? Like, why would you use a standard durable? The durability here is only referring to the UV resistance, not any other property of the coating. It doesn't mean it's more scratch resistant or more chemical resistant or anything like that. In fact, the super durable polyester resins are more brittle than the standard durable varieties, and so whereas standard durable polyester has, say, full impact, it has the ability to max out the impact resistance test of 160 inch-pounds. The super durable polyester is going to be a lot less flexible, more like 40 inch-pounds. Next, please. Crosslinkers. I probably don't have to get too far into this, but the carboxyl functional polyesters or acid functional polyesters in North America, we still use CGIC. It's pretty great, but there are regulatory issues. In Europe, they completely shy away from the use of TIC. Instead, there's HAA or Primid that they use as a curing agent. You can actually use acrylics to cure with a polyester. That is a useful way to adjust the gloss, because the incompatibility of them makes it actually a pretty nice lever to pull for a gloss adjustment. And then again, polyester with an epoxy in it is not going to be weatherable. Hydroxyl functionality, typically going to be cured with an aliphatic blocked isocyanate. Those have a blocking mechanism that comes off when it hits a certain temperature. The key thing here is that they have to be aliphatic. There are aromatic versions of blocked isocyanates, but those are not weatherable. Obviously not going to be able to use those for architectural coatings. A kind of a variation on the blocked isocyanate is the uratidione. That's they call it blocking agent free or self-blocked, but essentially they have a weak ring on the isocyanate. So instead of having a chemical or a substance that disappears and gets pulled out into the stack, uratidione just unblocks itself when you hit a certain temperature. And by I'm saying temperature, blocked isocyanates with the blocking agent typically around 170 C. The uratidiones might be 160 C, although I think they've developed catalysis methods to get it lower than that. And I mentioned TMMGU. That's a very specific. That's only for when you're making a wrinkle, but if you use that with a super durable polyester, you're going to be able to achieve the same weatherability as if you were curing it with an isocyanate. Next. All right, and then hyper durable is the term we use for the highly the AAMA 2605 Qualicoat Class 3, the most weatherable, UV durable coatings are out there. And the two, I guess, major chemistry types there. On one side we have PVDF. It's not as common in powder coatings. That's what they do use lots of in liquid coatings, though. It has a history. You can go and find a building or a bridge or a water tower that was painted 50 years ago, and it's still going to look good. The reason it's not as prevalent in powder coatings is that it's a thermoplastic as opposed to a thermoset. So it has higher molecular weight, higher melting temperature, and it's just more difficult to process using our standard powder processing equipment. There are, it's a small part of the market, but they do exist that people make powder out of PVDF, compound it with the pigments and the additives to make it meet the specification, and then you can spray that on parts and bake it. I'm not aware of any commercial functionalized, thermoset versions of PVDF at this time. But those oftentimes have an acrylic resin accompanying it. I know with the liquid coatings, that's common for it to be like a 70-30 with a PVDF and an acrylic, and it's not just cost reduction, but there's some properties you can get from that. And cost reduction, that's something to bring up, because that's another like, if someone says, why don't you just use these, the hyper durables for every formula, because then you never have to worry about weatherability. The resins themselves are 10+ times the cost of a standard durable polyester, and so they're very expensive, and so they really are only used for applications where they're required. Now, for traditional thermoset powder coatings, we have the fluoroethylene vinyl ether, or FEV, and those are a lot more like a typical powder coating resin. The melt point is in line with what we're used to processing things in the extruder, and the functionality is just like the hydroxyl functional polyesters right there. So they're cross-linked with the same sort of blocked isocyanates. The isocyanates are very weatherable, and so those don't hold you back as far as weatherability goes. There's occasionally these are blended as well with either a super durable polyester or a hydroxyl functional acrylic. Just because, again, the requirement says 10 years, and these can easily get 25 or 50 years of UV durability if they're formulated as a pure FUVE powder coating. Next slide. And then this, back to what I was saying about don't put in anything that is going to act as a bad actor. Pigments, inorganic pigments are a lot better than organic pigments in general when it comes to durability. I don't have to go through all these. Extender pigments, those don't usually have that much of an effect. By extender pigments, I'm talking about mineral fillers. Those can, improve corrosion resistance and scuff resistance and, some different properties, but they don't usually have much of an effect on UV, except calcium carbonate's not the greatest. That's usually used for more, low cost or interior applications. And then additives, You can improve your weatherability a little bit using UVAs and HALs. They work a lot better in a clear coat than they do in a pigmented system, just because they get, physically blocked by pigment particles, and if they're not available, then they're not going to give you any properties. But waxes are used in powder coating sometimes to have an effect on the surface, and so we put in a wax, it melts in the curing phase, and the waxes typically come to the surface, and that's why they're used for slip resistance, additional like scratch and mar properties. They can even be used to adjust the gloss. But since the wax has come to the top, if you use a non-weatherable wax, then it's going to very obviously be affected by UV exposure. So yeah, if you're using a polyethylene or something that's not weatherable in an otherwise highly durable coating, then you're going to get chalking, you're going to get photo bleaching, you're going to get very obvious signs that the coating is not weatherable. Next, please.
So this is back to me. So we just wanted to cover, to finish out with some active areas of research specific to architectural applications. And we have 3 major bullet points there. The top one is always going to be, almost always going to be related to some type of sustainability, especially right now. There's a lot of potential regulation around PFAS containing products. And as Nathan showed, both of the products that can meet the 2605 application, which are the highest weatherable applications, are fluoropolymers. And then we also didn't talk about it, at least I don't remember talking about it, PTFE or Teflon materials are used a lot to create textured powder coatings, and also to modify for mar resistance and scratch resistance, mostly mar. Now, without getting into a debate about what should happen or what we believe is going to happen, what you need to know is people are not taking the risk of not doing anything. So coating companies and raw material suppliers are trying to find materials that could replace these, which is much easier said than done. But at any rate, there's a lot of active research on PFAS-free materials or materials that don't contain any fluoro, because they may eventually become called PFAS-containing materials. The second bullet point, I talked a lot earlier, liquid versus powder on appearance. So on the powder coating area, there's always being iterative gains to close that gap in appearance. So expanding the color palette, making better metallics, smoother coatings at lower film builds, because you don't really need that high film build. You don't need 3 mils or 70 microns, 75 microns film build for any real reason other than to make sure that you're at least thick enough everywhere on the part and that the coating is smooth. So if you can get a smoother coating at lower film build, you would do that. Finally, enhanced performance, specifically improved flexibility. So Nathan talked about, he talked about 2603 versus 2604 in terms of super durable versus standard durable. But as it turns out, as you kind of go up in the specification, you start to lose some flexibility, which can cause problems with cutting and things like that. That's a kind of a combination of flexibility and adhesion. So that's an active area. Higher level of burnish and mar resistance is always going to be there, because you have parts hitting parts. This is related to those last 2 bullet points. You can get burnish and scratches and marring, and you can also get chipping and gouging during shipping and installation. So just to close it off, those are some active areas of research. And I don't know, Marcus, what the rule is. I'm okay to go over if we have some questions we want to field. But that's what we have to present today, and I appreciate everybody attending.
Yep, thanks, Eric. That is great. So members, we understand if you need to hop off, it is right at 2 o'clock, but we will continue on here with a Q&A if you're able to hang around a bit for that. And we'll also have a bit of announcements for upcoming webinars. So first question here. Due to weathering and corrosion on automobiles, is there a solution coating to restore the finish that is nationally US recommended?
To restore the finish. That's an interesting question, because we're talking about architectural, not so much about automotive specifications. Automotive specifications are a lot less, I'd say a lot less organized, a lot less universal than architectural ones. And so architectural, we have these standards that everybody kind of knows and everybody accepts. Automotive, it's, Ford and GM and Toyota and Nissan, and everybody's going to have their own set of specifications, and they're all pretty different. So I wouldn't say that there's a one size fits all solution to anything when it comes to automotive.
Thanks. We'll move on to the next one. Who makes the final decision on which types of coatings are used on architectural components?
Sure, I'll take that. That's not a straightforward answer. The easy answer that you would get if you ask most people and they just didn't want to tell you the details is that the architect is responsible for specifying the coating. And that is true. However, it's specified in a lot of different ways. So the architect can specify by AAMA class. They can say it has to be a 2605 coating. They can get deeper and say it has to be a 2605 powder or liquid coating, or one or the other. Or they can even specify a certain product if they want to, especially if they like the aesthetics of that product, because that's what they care most about. However, on those ones when they get deeper, it's usually has something after that specification that says or equivalent. And what that does, it allows the component supplier, so the window manufacturer in the case that I was talking earlier, to decide whether a different product is equivalent and apply that coating instead. Furthermore, that company can actually let that decision be made by the coater that they're using. If they don't do the coating in-house and they have a partnership with a certain coater, those coaters usually have 2 or 3 different suppliers for each type of coating for supply reasons. And the coater can actually choose if they're just told, apply a 2605 powder coating to this. So it's not straightforward. The architect does have the ability to dictate which type of coating is being used, but I would say that's not the common case. It's usually someone further down the value chain.
All right, thanks, Eric. Next one. This is on PFAS replacement. What is the latest technology in terms of replacing fluoropolymer in AAMA, or I guess that's AAMA, you're saying, 2605?
So that's a tough one, because if I tell you about the technologies, then I'm kind of talking about companies. So there's no, in my mind, I'll answer it now. I'll ask Nathan if he has a different opinion. In my opinion, there's no specific technology like a chemistry that's available to multiple companies that can meet that is commonly used and approved for use. There are companies working on more proprietary type technologies out there. None of them that I'm aware of, and I've been pretty interested in this market. None of them that I'm aware of are making any heavy gains into the market yet, but there are at least 1 or 2 of them that are in different phases of field testing. That, as we mentioned before, Florida weathering takes quite a while, so to get confidence in these products takes quite a while.
Yeah, it's back to that old conundrum of, like, even if you have the greatest polymer in the world and you know that it's going to last forever, without actually proving it 10 years in Florida, the market's not necessarily going to take your word for it. So we know that there are people working on it with different types of polymers, but it's a real uphill battle to have to do all the artificial testing and benchmarking things against stuff with known performance, but how do you jump into something and say we expect this is going to be great in 10 years without actually being able to demonstrate it? That's why I gave the example earlier, but you can go to a building in Japan and point at it and say, that was coded this many decades ago, and know exactly how it looks.
All right, next one. What temperatures are generally used for deblocking? I think this is isocyanate. Isocyanate?
Isocyanate.
It's spelled wrong, so it's yeah. There's an A missing there. You pronounced the word right, Marcus, the way it was written now.
Oh, okay.
The typical caprolactam blocking agent that's used comes off at about 170 C. And there are some other options out there that go at lower temperatures. I did mention uretdiones, like more like 160, but those can be catalyzed down into, at least there were some products at one point that were touting 130 for a deblocking temperature. But there are some other blocking agents besides caprolactam that get down into the 160 or even 140 range. They're just a lot less common. They're more expensive, and the name's escaping me, but there's also potential toxicity profiles that aren't an issue with epsilon caprolactam.
All right, I think that's all the questions we have. Let me update you on a couple of, or the rest of the webinars for September. On September 19th at 1 o'clock, we'll have 2024 litigation strategy updates, Rule 702 amendments, third-party litigation funding, and MDL Rule 16.1 proposal. This will be presented by Eric Lasker, Robert Johnston, and Brett Clements, who are all partners at Hollingsworth LLP. On September the 24th at 2 o'clock, this will be on a Tuesday, we'll have our state affairs update. And this one will cover Connecticut, Illinois, New Jersey, and Vermont. We will have ACA's lobbyists who represent us in those states present on what's happening on the ground. And on September the 26th at 1 p.m., we will have paint and coatings raw material supply. This will be presented by Doug Bone, Director Orem Boss Consulting. Eric Casebolt, Nathan Biller, ChemQuest, thank you so much for spending this time with our members this afternoon. Sorry we ran over this afternoon, everyone, but it looks like most people stayed on, so not a bad thing. But thanks again, and we'll see you all on the next webinar. Everyone have a good afternoon.
Thanks, we appreciate it. Take care.
Thanks, everyone.